So here we have example 2.7. This is a circuit with a dependent source, so it's similar to the last KVL KCL one we did, although it has this dependent source, which we're going to look how that works out. It's pretty easy. But what we're going to do here again, going to use the same equations. The problem asks, it says here's the circuit, apply KVL and KCL to determine the amount of power consumed in the 12 ohm resistor. So we're trying to find the power in this resistor. So in order to find that, we're going to have to know what the current is going through here. And in order to find that current, we're going to have to solve the entire system. And so we're going to get started with that. So the first piece that we were given is the I1. So let's add in our I2. We're going to just draw this down here as I2. We're going to add in our I3. Okay? And now what else are we going to do for this one? I think that's it that we have to write up. So the next bit now that we're going to have to draw is how we solve it. So the first bit to solving it, we're going to do Kirchhoff's voltage law. So the voltage law, the first voltage law, we're going to find the loop that we're going to go around. That looks like that. We're going to find the other loop we're going to go around. That looks like that. I drew through it, apologize. So these are the two loops that we're going to do, and then on top of that we have the Kirchhoff's current law, which is that point right there. So what we're going to do is we are going to start solving this. Is there anything else special about this? Oh yeah, the dependent source. So as we've seen before, a positive and a negative means this is a what type of dependent source? This is a voltage source. And what's controlling it? Current. So this is a current controlled voltage source, CCVS, current controlled voltage source. So essentially that's saying that this number, 8 times I1, is the voltage coming out of this. And remember, it follows the same thing like a normal battery, except you have I. So if I1 happens to equal 1, if we solve it, then this is going to equal an 8-volt source. However, we're going to solve through that, and you're going to see how this works out. So let's start with the first bit, which is KVL1. KVL1 is this loop here. So for this loop, we're going to go through the power supply first. So we're going to do a minus 20 volts. And then we're going to have this guy. So that's going to be plus whatever this is. So this is going to be what? 4 ohm times I1. Because V, remember V equals IR, so the voltage plus the voltage. Then we're going to continue down this loop. We're going to get a 8 ohm I2. And we're back to the beginning, so that's going to equal 0 there. So we're going to straighten this up a little bit. I'm going to pull some of the units out. So we are going to get 4I1 plus 8I2 equals 20. Excuse me, guys. There, because we pulled that to the other side. Cool. All right, that's KVL1. Let's do KVL2. KVL2 is going to go, again, we're going to go through this again. So we're going to start here and just work our way through. So we have, what is this, an 8 ohm resistor here, but we also have already drawn that the current I2 is going down. So what does that mean? If we're going against the current, that means it's opposite sign. So opposite sign equals negative. So we're going to get 8 ohm times negative I2. Then we're going to go up here. So this is going in the correct direction of the current. So we're going to go plus 12 ohm. And this is I3. Then we're going to come down here, and so we're going to go with this. And remember, we're going negative to positive, so that's going to be negative again, so that's actually plus negative. And then this is the voltage, so it's going to be 8I1. And now we're back in the center, so we're going to go to 0. So if we simplify this out, we're going to go 8 minus 8I2 plus 12I3 minus 8I1 equals 0. So we're going to solve this, rearrange this just a little bit nicer. So it's going to be minus 8I1 minus 8i2, 12i3 plus 12i3 equals 0. So that's our second equation there. And so we're going to save that one up. This is our first equation. We're going to save that one up too. And now we need one more equation, because right now we have 3 unknowns, so we need 3 equations to solve those unknowns. So we are going to go for our KCL. So we're going to go over here and do KCL, and we're going to solve KCL by, remember, in equals out. Into a node equals the out of a node. So here we've got an I1 coming in, equals, and then these are the 2 coming out, I2 plus I3. And that's it for that equation. It's a really simple one. So how do we put these all together? Well, you can do it, actually we're going to box this because that is our equation that we're looking for. So we can either substitute all these in and spend a lot of time doing that, or we can use our handy dandy calculator and solve this real fast. So let's get this into the correct form. So right now we're going to do I1, I2, I3, number. And so for the I1, we're going to go to KVL1. So this is going to be 4, because remember this is the matrix here. And this is the matrix here. And then remember this is the solution matrix that you're going to multiply it by. So it's the answers, just hard numbers that they come at the end. So we've got 4 from I1. We've got 8 from I2. We don't have an I3, so it's going to be 0. And we have 20 as the number. And then we have KVL2. So this one's going to be minus 8. Then we're going to get a minus 8 here. We're going to get a 12 here. And we got a 0 here. And then for this one, remember we can push these all to the side, or however you want to do it. I'm just going to push them all to the left side. So this is going to be I1 minus I2 minus I3. So that's going to be 1, minus 1, minus 1, and there's 0 constants remaining. So those are our matrices. So let's go and solve this system then. Remember, just so we have this, matrix A inverse times matrix B equals solution set. What we're looking for. So with that being said, let me line that up a little bit more. There we go. So with that being said, we're going to pop this calculator down. We're going to do a math matrix. We're going to go to edit. Going to go to edit matrix. It's a 3 by 3 good. What do we have for this? We have 4. We have 8. That was not an 8. There we go. 4, 8, 0. We're going to go down here to minus 8. K, minus 8. K, 12. That came out as 10. I'm typing wrong. 12. And then we got 1, minus 1, minus 1. Let's just double check that. 4 minus 8, 1. 8 minus 8, 1. 0, 12 minus 1. So that looks good. So we're going to do a second quit. And then we're going to do a second matrix and edit B, which is a 3 by 1 matrix. So this one is going to be 20, 0, and 0. Cool. I'm going to quit that one. Now we're going to do a second matrix A. And remember, if we use this one here, up minus 1 times second matrix B, answer. And now, so those are our answers. Let's see if we can make that a little nicer. So I think we can do second math, if I remember right. Let's try this. Where is math? Second math. No, just normal math. I think we can convert that to fractions. There we go. Nice. Okay, can we read that?
Yeah, we can see that. It's not the best, but 25 over 7, 5 over 7,
20 over 7. So that means I1 equals 25 over 7, and what's the unit? Amps. I2 equals 5 over 7 amps. I3 equals what is that, 20 over 7? Yeah, 20 over 7 amps. So those are our solution set. But remember, the problem asks to determine the amount of power consumed by the 12 ohm resistor. So we're going to finish this off, we're going to do power equals IV, because that's the equation for power that we have. And now we're going to be able to solve into it. Because remember, V equals IR, same thing that we had over here. So we're going to be able to do power equals I, and then V equals IR, okay? And remember, this is the power in the 12 ohm resistor equals the current going through the 12 ohm resistor, which is I3 times 12 ohms. So power in the 12 ohm, I'm just going to write that down as power 12, equals I, and we know that's I3 because it's what it says up here. And we know this one is I3 because it's the same thing. And we know this is the 12 ohm resistor, so that's going to be equal to, so power equals now to I3, which we have 20 over 7 times 20 over 7 times, the resistance there is 12, and power is going to equal 98 watts. So that's how we solve that one again. The only real difference between this and the last was this current controlled voltage source, which isn't really a big deal. They do get a little more complicated, but for now this will do fine. So hope you enjoy. On to our next one.